Hello, today we're going to talk about canon physics. We're going to talk about drag. We're going to talk about the horizontal and vertical components of velocity. So I'm just gonna get the variables right. Okay, so here is a variable. So you see this launcher is powered by springs, but it doesn't matter. So we have the spring constant 200 newtons per meter. That means they apply 200 newtons for every meter they are squeezed or stretched. Here they are squeezed. When when they when they try to when I start the simulation, they they expand, they push on the guy and throw him into the air. The spring actually, we have two springs, so actually it's 400 newtons per meter, the force that's we're applying. So gonna get in position. 3, 2, and I'm gonna put the graph up here so you can see it. 1, go! Now let's look at the graph that has been created. So you see this pink line is the actual speed and then the light and dark purple are the vertical and horizontal components. So this light purple line shows the horizontal component. This is how much of the speed is on moving forward. And then this is the vertical component. How much speed is about moving is going towards moving is going towards moving upward or downward. So let's analyze this graph. So this big jump is when we launch him out of the cannon. Then this curve is the moment is his air time before he hits the ground. And this curve looks wavy because of the way he turns. It changes his air friction. How much air friction he has, and that slows him down. So the crests of the wavy part is when his head is facing forward or backward. Well, and these troughs are when he's straight up and down. And then this is where he hits the ground. He bounces and hits the ground again until he comes to a complete stop. Now, why does this one dip down? Because gravity pulls him down, and that directs his velocity to down till he's down here. It gets a little straighter after that bounce because he's not high enough in the air to So now let's try this again, but with the different one, X and Y position over time. Ready, set, go. So let's talk about the graph now. So the pink line is his X position, how far he's traveled. The Y, and this is the Y position, how high he's traveled. So apparently he's gotten 30 meters in the air, and he's been able to make it to 100, and he's been able to make it to he's been able to make it to 110 meters high in the air. He was able to make it 110 meters approximately. So this brown line is the Y position over time. It accurately shows how much he bounces. You see how this hump is 0.25 times bigger than this one? That's because the restitution of the ground is 0.5, and his restitution is 0.5 as well. And 0.5 times 0.5 is 0.25. So he bounced 0.25 times, or 4 times lower than he flew originally. And that concludes our presentation. Thank you for your time.